Wes here with SureTechAssembly.com. Someone once said that there are 1,000 ways to die, and that's certainly true in wire and cable termination. This series will take you through some of the common failures and their causes. Today we'll look at insulated products known as closed barrel terminals, and in particular fast-ons. These terminals come in a wide variety of shapes, sizes, and applications. They are sometimes known as plastic grip or PIDGE terminals. Because the insulation covers the actual termination, inspection of the product can be difficult. Crimp height is not available through the normal system of checking by micrometer. Visual inspection is possible, but often difficult to see clearly. A pull test can also be applied, but is not 100% in ensuring the termination is correct. So I'd like to demonstrate for you a common failure that is very difficult to detect. We'll be using a 22 gauge fast-on, corresponding wire, and the appropriate applicator for the terminal that we'll be applying. We'll be using the G-press to make the termination. Okay, I've got the G-press all set up with the applicator and it's ready to roll. So let's apply a terminal appropriately that reflects a quality crimp that would pass inspection. Now I'm going to simulate over-crimping the terminal by just a few thousandths of an inch. This could occur in an applicator or this could occur in a hand tool. In either case, something happens to the terminal that is not easily seen but creates a quality issue that can appear either in the field immediately or perhaps down the road. Pay careful attention to what happens to the terminal in slow motion as it is crimped. Right there, something happens that should not. So let's take a look at the finished product and evaluate what exactly happened and why this terminal would fail in the field. Now here are 3 leads all crimped on the same applicator but with different crimp heights or pressure applied. Remember, only by a few thousandths of an inch. One is a quality crimp, one is marginal, the other is a failure. So let's put it under the microscope and see what happened. Now before we take that up close view, notice that I can pull on all 3 of the terminals and mechanically they are all sound. A pull test would simply not reveal which of these terminals is good and which is bad. However, under the microscope we can see that the terminal that had the extra applied pressure has separated. The actual crimp is split in half, and while the wires have maintained their mechanical position, the terminal is deeply compromised. The termination may fail immediately in the field, or it may become intermittent, or it may fail when an installer plugs in or unplugs this fast-on to the end product. In either case, we have a terminal that is unreliable. Hope this information is helpful to you. If you're looking for quality cable assemblies at super competitive pricing, check us out at SureTechAssembly.com. Thanks again for watching.